Today we're going to talk about global and maxima and minima. So what I would like for you to do is sketch a graph with the endpoint on the positive y-axis is 0, 4, a minimum point at 2, negative 7, and a maximum at 6, 6, a minimum at 8, 2, and then an endpoint at 10, 8. So I sketched this in with my hand, of course, and we can see the graph. What are the differences between global and local maxima and minima? Well, the difference between global and local is that in the global, at some point P, f of P is less than or equal to all of the values of the function of f. And when you have a maximum, P at the point P, f of P greater than or equal to all values of the function. If a function is continuous with no defined interval, then there is no global maximum or minimum, just like this one. Here, we have the very lowest point on this graph is right here. The very highest point is here because it has a defined interval. In this one, if we continue it, put these arrows on the end, then it has a local maximum, minimum, local minimum, local minimum, local maximum, because all of these values continued are going to be lower than this minimum and are going to be higher than this maximum. So how do we find the global max or min? Well, first we find all the critical points. Now in this particular case, you are given endpoints. So here I have the critical points we find by taking the first derivative. Yes, you're right. So we take the first derivative and we find the critical points. We know the endpoints, so now what we have to do is find all of those values. So we plug this into our calculator, the original function. So we go to y equals and we plug in the original function, x cubed minus 6x squared minus 36x plus 1. And we graph it. I'm not sure. Okay, so I have a syntax error. What's that mean? Go to, let's see what the problem is. Oh, I didn't put in a number there. Okay, so x cubed minus 6x squared minus 36x plus 1. Do I have it right now? Yes, we have a graph. Okay, but we can't see everything, so let's go to window, and I have the window there for you, negative 10 to 20. Those are my x values, and my y values are going to be negative 250 to 50, positive 50. Okay, I see a beautiful graph. This is one that has endpoints, so we will be able to define a global maximum and minimum. But as it is here, this is a local maximum and this is a local minimum. So we plug those values in and we get all of the points. The very lowest point will be the minimum, global minimum. The highest point will be the global max. Others, you have to look at the graph to determine if it's local maximum or minimum. So when I plug in negative 2, trace negative 2, I get 41. That's a max. And if I plug in a 6, I get a minimum of 200, negative 215. Those are the critical points. For the endpoints, I plug in 13, and I get a very big number, 716. And then if I plug in negative 5, I see negative 94. So those are my critical points and my global max or min, my local maximum or minimum, just with the critical points and the endpoints. Here we have another one, example 2, 3 minus x squared. You use the endpoints negative 4 and 3, but then we want to take the first derivative, set it equal to 0. X is 0, so the critical point is at x is 0. When I plug 0 in, I get 3. That's a global max, because this is a parabola opening downward, so this is global max. And then the endpoints, negative 4, negative 13, 3, negative 6, that's a local minimum. This is a global minimum. If f is continuous over an interval from a to b, for all the critical points between a and b and the endpoints a and b, then determine if the function over the interval has a global maximum minimum. Number 36, we have, if you have 100 feet of fencing and want to enclose a rectangular area up against a long straight wall, what is the largest area you can enclose? So here's my wall, and here is my width, here is my length. The perimeter of this will be 2w plus L. The area is length times width of any rectangle. We know that we have 100 feet of fencing, so the perimeter must equal 100 feet. So we're going to say 100 is equal to 2w plus L. So what we're going to do is I'm going to move this 2 over by subtracting it, 2w, so I have the length is now 100 minus 2w. So that when I plug this into my area formula, I have one variable, 100 minus 2w times w, and when we multiply this out, we get 100w minus 2w squared. Take the derivative, find the, set this equal to 0, plug this 25 back into my length formula, and I get that my width is 25, my length is 50. If I multiply those two, then I get the total square feet. So there's a critical point at w is 25. The graph is a parabola, it's concave downward, and the critical point then is going to be a global maximum.